Welcome to our YouTube channel TENACITY Online. This is the fourth class on the chapter Motion in a Straight Line. So in the last class we have discussed about instantaneous speed and we came across the new concept called differentiation, right? So in this class we will be dealing with the concept differentiation and integration. First of all, what is differentiation and integration? To understand in a simple term, we will say differentiation to be the advanced division and integration to be advanced addition. I will show how it is advanced division and advanced addition in the meantime. So differentiation is used to find slope of any curve under the graph, in which integration is used to find the area under a curve. So before understanding what differentiation and integration is, let us look what slope is. You draw a graph such that you draw a line under this graph and mark an initial and a final point, and mark it initial point as x1, y1 and final point as x2, y2. So the slope of a line joining two points is defined as the change in the coordinates of y-axis by the change in the coordinates of x-axis, that is delta y by delta x. So you consider an angle theta which is made by the line with the x-axis. So generally we call it as inclination of that line. So tan theta is defined as opposite by adjacent. So delta y by delta x. So slope can be written as tan theta. So this is the concept of slope. We have studied slope of a line joining two points, and we can calculate that by knowing the formula delta y by delta x or tan theta. But when a curve is given like this, how will you find the slope? So for that you have to consider a very small interval, so that when you zoom in, you will know that this is it looks like a straight line. So you will plot that to the corresponding axis. So now you can write as dy, it is a small change, it is dx. So this is differentiation. So no need to go deep through this for this chapter. Just learn the formulas which I will give you. Okay, don't get tension about seeing the concept and derivation of it. I will not going to discuss any derivation of differential equations. I will just give you some formulas related to it, and you will get to know how to deal this topic in this chapter. I will give you the formulas now. First, d by dx of x power n is equal to nx power n minus 1. This power comes behind this nx, and this power gets decreased by 1. So this is the first formula of differentiation. The second formula is d by dx of sin x, and that is equal to cos x. And d by dx of cos x, and that is equal to minus sin x. And in trigonometric ratios you will get three trigonometric ratios starting with letter C, that is cos, cot, cosecant. For that differentiations you will put a negative symbol like this. For the trigonometric ratio starting with C, you keep this in mind. And fourth one, d by dx of any constant is 0. So these are the four formulas which are important to you as for now, and you concentrate on these formulas, and that's enough. No need to go deep into this chapter. Just know the concept for which differentiation is used and for which integration is used, and then you know the formulas, and I will show you how to implement these formulas in solving the problems related to this chapter. I have discussed formulas of differentiation. Now I will discuss the operations related to differentiation. d by dx of u plus or minus v is equal to d by dx of u plus or minus d by dx of v. So you keep this in mind that u and v should always be written in terms of x. If it is not written in terms of x, we should consider it to be some constant, and this differentiation will be 0. So always you have to write the functions in terms of the given variable in the denominator. You keep that in mind. And d by dx of u into v is equal to u into dv by dx plus v into du by dx. And the third one is division. d by dx of u by v is equal to v du by dx minus u dv by dx whole divided by v square, that is the denominator square. So I hope you are clear with the operations of differentiation. Now let us discuss some problems related to differentiation. If some function u is written as x square plus cos x minus sin x plus 2, and they have asked you to find du by dx, what will you do? So you know that d by dx of u plus or minus v is simply d by dx of u plus or minus d by dx of v. It holds good for any number of terms which are written. So you can write it as d by dx of x square plus d by dx of cos x minus d by dx of sin x plus d by dx of constant 2. So what is the value of d by dx of x square? As I said, d by dx of x power n to be nx power n minus 1. You can write it as this n, let 2 be n. This 2 will come in front of x and the power decreases by 1 plus d by dx of cos x, I said minus sin x. And minus of d by dx of sin x is cos x, minus cos x, and d by dx of constant is 0, so 0. So the final answer is 2x minus sin x minus cos x. So this is how you do differentiation problems. Let us discuss integration. Integration is denoted by a symbol like this. This is the denotation of integration. So integration is divided into two types. Those are definite integration and indefinite integration. And as I said, integration is advanced addition and it is used to find area under the curve. Now definite integration has fixed intervals. In which indefinite integration don't have fixed intervals. That means when you are doing addition from number 1 to 10, it has intervals between 1 and 10. You will do addition of those numbers 1 to 10. But when they say you do the addition of all the natural numbers, it will start from 1 and it will not end. Like that integration also. When definite integration is given, it will contain fixed intervals. That is, they will give up to in which interval you have to integrate. That means you have to add. In definite integration, they will not give in which interval you should add the values. They will not give the intervals. Okay. So as I said, we can find the area under a curve. I will show you how to find the area of a triangle using this concept integration. So before that, let us see the notation of integration. Generally, integration is written as this symbol with some limits and function y and dx is also written, in which this y function is written in terms of x. This is the notation of integration. I hope you are clear with this. And I have to discuss some formulas related to integration. You just have to keep this in mind. Okay. So integration of lambda y dx is written as, the constant can be taken out, that is lambda into integration of y dx plus c. This is some constant. They have not given intervals, so I am writing the constant. So integration of x power n dx is equal to x power n plus 1 by n plus 1 plus c. This is the second formula, and the third one is integration of sin x is minus cos x plus c, and the fourth one is integration of cos x is should not forget writing dx. Cos x is sin x plus c. And I want to say you one important point, that is integration is exact opposite to that of differentiation. If you do differentiation of this RHS part, you will get this value. You try it once. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x, but the negative symbol is written in the RHS. And differentiation of this will be x power n. You do this, you will get the value. I will show you how you will get d by dx of x power n plus 1 by n plus 1 is equal to, as this is a constant, you take it out, 1 by n plus 1 into d by dx of, what is the differentiation of x power n plus 1? To take this to be n plus 1 to be n now. Okay? So when you take like that, you will get that 1 by n plus 1 into n plus 1 into x power n plus 1 minus 1. Cancel, and you will get x power n. This is how you can judge that differentiation and integration are exact opposite terms. These are the four important formulas related to integration. Now I will show you how to find the area under a curve by showing you to find area of a triangle. Write a graph. Write a triangle. Let this be base and this be height. Okay? This is O, this is A, this is B. Origin, a point A and a point B. Y-axis and x-axis. So you consider a short part of this triangle. So this is a small part. It looks like a rectangle, right? So this is dx. Okay? And let this be y. And area of this be A. A is taken already, right? So you take this to be C point, this to be A. So you are finding area of this triangle. So first you integrate the area of this rectangle and you will get the area of this triangle. I will show you how. So integration of, you multiply this, area is equal to area of triangle is equal to integration of y dx. So the function is y. We have to write y in terms of x. You see the triangle OA and D, from triangle OAD and triangle OBC, they both are similar, so that h by y is equal to take this to be point, to take this to be, its length to be x, h by y is equal to b by x. So y is equal to h by b into x. So you substitute that value here. So integration of h by b into x dx. Okay, I hope you are clear with this step. As h by b is constant, you can take it out. H by b into integration of x dx. So now the interval is from 0 to b. So you write it here. Okay. H by b into, what is the formula of integration of x power n? It is x power n plus 1 by n plus 1, right? So you can write x power 1 plus 1, that is 2 by 2, and the interval is from 0 to b. So in the place of x, you have to substitute b. And I forgot to say you something, that when you get values like this, you have to do, when you get x square by 2 and interval from 0 to b, it should be like this, that is b square by 2 minus 0 square by 2. You have to substitute this both values here and subtract those values. Okay, now as this is 0, there is no need of subtraction. You can directly write h by b into b square by 2. Now what will you see? B and b square, it get cancelled. Now you will get half into base into height. So this is area of triangle, as we know. So this is the proof of integration which I can say you. So this is about integration. So you just stick on to the formulas and no need to research, as I said you. Just by looking at this theorem or proof, you can understand that integration is true, and you can focus on the formulas for solving problems of this chapter. I hope you are clear with this. Let us discuss the concept of maxima and minima. So what is maxima and minima? Maxima is the maximum value of a given situation or a given value. It is the maximum value. Minima is the minimum value. So suppose we'll draw a graph. And I will draw a path like this. So the maximum value is this, of this curve. And the minimum value is this. So now what is the slope of maximum value of this path, that is 0. Slope is equal to 0, and the minimum value slope is also 0. So what I said, differentiation is used to calculate the slope of a curve. So maxima, for maxima, dy by dx is equal to 0, and for minima also dy by dx is equal to 0. So this is the application of differentiation. This is all for today, guys. So I would like to conclude this class now. We have discussed differentiation and integration on the surface level, and I think that is sufficient for solving problems related to this chapter. And I will be solving the problems related to differentiation and integration, and applications of differentiation and integrations will be discussed in the next class. So till then, stay tuned. And we also discussed some applications of differentiation and integration in this class. I hope you are clear with this. If any doubts you are facing, please put it in the comment section. We will definitely reply to that. And please share this video to everyone you know, so that they get aware about the channel TENACITY. So I would like to thank all of you for watching this video, and please share, subscribe and like. So thank you so much.